Hey, what's up, guys? This is Sheng here. So today let's take a look at 1655 distribute repeating integers. Okay, so you're given like an integer, an array of n integers where there are at most 50 unique values in the array, right? And then you're also given like an array of m customers, other quantities. So each quantity means how many how many numbers this this customer is going to get, right? And the integers ith customer gets all are all equal, and every customer is satisfied. Okay, so blah blah blah. Return true if it is possible to distribute numbers according to the above conditions. So basically, what it means that we have a long list of numbers, but there are like only at most 50 different numbers. So which means that we can group those numbers together within like a size of 50 dictionary hash table, right? So we have a numbers here, right? And then the first example is one. It's like this. So basically, the first customer he wants two numbers. He wants he wants two, not two numbers. I mean, he wants two same numbers, right? But we only have four different numbers whose count is always only has one. That's why this one is false. We cannot satisfy that. The second one is true because since the first customer wants two same numbers, and we have 2 3 here. That's why this one is true. And same thing for this example 3 here, right? So we have two ones and two twos, but and then the two customers, they want like two same numbers and another two same numbers. So we can give the first two ones to customer 1, and then we give this two to this customer 2. All right, so on and so forth. Okay. This is another one, right? We have 5 ones, so we can give 5 to customer 1. We can give three ones and then 2 ones to 1 and 3 ones to customer 2. All right, so here are some very important constraints here. So, I mean, there are at most 50 unique values in nums. We already know that. And then the customers, there are only 10 customers. Okay. So what do we have? So we have like a list from 0 to 50. Each num we have a list. This one has a different number, have different count, 10,000, 10, or even 88. Doesn't really matter. So here we have a count hash table or a count list. It doesn't really matter. Actually, we don't care about the value of the numbers. All we care is the count of each numbers. So we have a list of counts for 50 different numbers. And then we have what? We have a 0 to 9. We have 10 customers. So we have 10 customers. And each customer also wants some numbers from this count, right? We have a different 2, 6, 5, 7. And the question is asking us, can we somehow distribute this count of numbers so that we can satisfy each of the customer? Okay. I mean, so for this problem, there is like a greedy solutions. Basically, I think that solution is like a greedy plus backtracking, where we sort the quantities in a reverse order. Basically, we're trying to satisfy the customer who wants the most numbers, and then we try each of them in this count. We also sort this count from the biggest to the smallest, and every time when we if we cannot satisfy this customer, we simply return false. If we can satisfy everything, all the customers, we return true. I mean, that one can can actually pass all the test cases, but to me, I don't think that's 100% correct. But I cannot approve. But I can't approve that. That's why I'm not going to talk about that solutions here. Instead, I'm going to talk about the DP solutions here. So every time when you have like this kind of two like conditions, right? You have like a candidate and then you have another like this thing. This one is like similar like the different people can wear hats, right? Basically, we have different candidates and we need to assign some numbers to these customers. But the difference for this problem is that we can assign multiple customers to the same count here, like the last example here, right? For this one, we need to assign multiple customers to the same count here. Yeah, so that's that. And so for this kind of problem, it's always I think the one of the template is that for the DP, right? So the first one is we're gonna always have a mask here, we have a mask and then we'll have an index. So that's gonna be the common template for this problem. And who is gonna be the mask? Of course, so whoever is smaller will be the mask. And in this case, it's gonna be the customer, right? So the customer is the mask, and the index, of course, is a count. Is the index of the count. So we need this index because we don't want to go back. Basically, the index means that the DP index means that from 0 to index -1, 0 to minus index 1, and with the mask means that which customer has been assigned to some numbers. What's gonna if it is true, right? Because this thing in the end will return either true or false. It's gonna be a Boolean type, right? Yeah. So we start so with that, what's gonna be the next? The next thing is that every time when we add a current index, right? Let's say we're at this index, and the count for this number is 10. Okay, so the count for this number is 10, and so what's going to be the scenarios at the current state, right? Let's say we have the mask. The mask is, of course, going to be either 0, 1, 0, or 1. It doesn't really matter, right? I mean, we could use 0 represents the customers who doesn't have has not been assigned, or vice versa. Either way is fine. But for this problem, the let's say we have an index, right? And we want to know, because since we might be signing multiple customers, right? With the same account number here. So which means that let's say one means let's say zero means that the customer who has not been assigned to the numbers, which means that we have to get all the subsets. Since we have 4 here, the subset, I mean, of course, it's all the subsets among all those kind of 4 zeros. We have to try all of the subsets because we don't know that, and that's why we have to try all the subsets with the current mask. So the subsets, I mean, it's like this. I mean, so the first subset is, for example, we have this one, right? The first subset of that is 1, 1, 0, 1, 0, 0. I'm going to remove this thing here. So which means okay, so the first case is that this customer will be gets assigned to this one, and second one is what? It's like now with this one, right? And then here the third one will be this one will become to 1, right? And so on and so forth, right? And that's the first customer case, and then the second one is then the next one will be the two customer case, right? So we assign 2 customers with this count here. So we're going to do 1, 1, 1, 0, 1, 0, 0, 1, 1. And then what? and then we have this two and 1 0 1 1, this two 1 0 1 1, and then so on and so forth, and then 3 and 4. So basically, we have to find a very efficient way to give us the subsets based on the mask, right? And to do that, you know, there is like a trick to do it. There is a formula to do it, but to do that, we have to do it in a reverse way, which means that, we have to use one represents the not assigned customer, and zero represents the ones that has been assigned. So we have to reverse the definition of this bit mask. Why is that? And I will give you an example here. So let's say we have this mask. All right, let's just use that example here. And the formula is like this. The formula is a current one, the current mask minus one, and then do an AND with the current mask. So that's that. So that's the formula to get the next subset. All right. So the way we're getting the subset, as you guys can see here, so at the beginning, this current one will be the same as the mask here. Okay, and the subset is like this. So when the current one, sorry, so when the current one minus one, so what do we have here? We have 1 0 0, 1 0 0, 1 0. Yeah, and then if we do a AND mask here, right? AND with mask, what do we have here? We have 0, sorry, we have 1 0 0, 1 0 0, 1 0, right? As you can see here, now we have a different mask here, right? So the one got removed in the end, right? And how about I mean, if we keep going, right? Now this one is the current, right? So if we do another minus one for this one, we have 1 0 0, 1 0 0 0 1. And if we do a bit and with the mask, this is the mask, right? This is the mask. Again, what do we have? We have a 1 0 0 1 0 0 0 1. Sorry, 0 0. I'm sorry. 0 1 and 1 1 is yeah. So this thing will be the current. So this is the current one, right? So this is the current one. And as you guys can see here, right? So we are like actually getting all the subsets for the ones, and you can keep going, and I'm not going to keep do more stuff here. I mean, I'll do one more thing. So let's do another subtract by one. So 1 0 0 0 0, right? And then if we do a AND with that, what do we have? We have 1 0 0 1 0 0 0, right? So this is the second subset, as you guys can see here. So we have this one here, right? This two one here, and we can keep going. So the next one will be 1 0 0 0 1 1 1 1, right? And then if we do another AND here, it will be 1 0 0 0 0 0 0. Okay. So here, if we do another one, right, we're gonna have like a 0, 1, 1, 1, 1, 1, 1, 1, right? And then if we do another AND with that, what do we have? We're back. So now the first one will be 0. Now we have 0, 0, 1, 0, 0, 1, 1, right? So this is the new one, as you guys can see here. So now we're removing the first ones here. We have these 3 ones left. Anyway, so that's how we can calculate the efficiently calculate the next subset from a bit mask. And since as you guys can see here, we have to use like 1 as the remaining parts. So which means that we will start from our starting point of the mask will be 1 1 1 1 1 1. And in the end, when we reach the 0 state, we know that okay, then it means that we have assigned all the customers with some numbers. Then we can return true. Okay, cool. So I will just start coding here. During the coding, we'll also be implementing some of the pre-calculations, but I will try to implement mm, I'll try to implement the main logic first. So like I said, we're gonna have like a DP, right? So for the definition of DP here, we have 2 state. The first one is the index, and the next one is the mask, right? So I'll be using like the Python's way of doing the memorizations here. So if the mask is equal to 0, then we know okay, we have assigned all the customers with some numbers. That's when we return true. And else if the index is in okay, so to do that, let's try to count the numbers first. Okay, so the count will be we do a counter, right? We do a counter of the numbers, and all we need, we just need the values, right? We don't need the keys here, so that's why we do a values, right? And then we will convert this thing to a list, right? So that's how we do it. And then we have n equals the net length of the count, and then we have m equals the length of the quantity, right? And then here in the end, we simply return the dp of 0 and what at the beginning we have 1. They're all ones. All ones means that this one, just do a left shift by m and then -1. That's how we get 1 1 1 1, right? Okay, back to this dp here. Yeah, back to this dp. So and when it's going to be the negative case. So if the index has reached the end of all the counts, then we know we need to return false, right? So that's that. And now the next one is what is the answer, right? So the answer is what? So with this kind of problems, an index is all. There's always like a case where we can either pick this count or we don't pick. That's why for this kind of problem, the first one is going to be always the not pick would be the index +1, right? If we don't pick it, then it means that the mask didn't change at all. So we can simply do a index +1 and then the mask, right? So not use current count, right? The second one will be use current count. So to use current count, I think we can just do a quick check here. I mean, if not answers, then we use it, right? But this thing is optional because if this one already returned untrue here, we can simply return the answer, right? We don't have to continue. But this is optional. It won't affect any of the time complexity here. So, okay, so now we need to get all the subsets, right? Try all the subsets of mask. And here there's also another difficulty here. I mean, let's go back to this example here. 100, 1101. Let's say that's the current mask. And 0 means those customers have already been assigned to a number, and one means those are the customers we need to consider right here. And to efficiently, let's assuming we have this kind of mask here, right? So let's say there's a well, current, I'll write the formula first. So at the beginning, the current is mask, right? And then the formula is like this: while the current is greater than 0, because we're removing each of the ones. In the end, everything will become 1. That's when we stop, right? We have a current equals the current minus 1, right? And then we do an AND with mask, right? And that's how we get the current. So the current is like this: 1 0 0 1 1 0 0, and something like 1 0 0 1 0 0 0, right? Something like that. Basically, the subsets of replacing any number of ones into with 0. So now the next problem comes down to let's assume we have removed we decide to use these two customers with this current index. What's going to be the condition of using that, right? So the condition of using that is that we have to know if the quantities of those two customers is either equal or smaller than the current count. If it is, then we can use it. Otherwise, we can't. Okay. So if we do a but while we're doing the subsets, and as you guys can see, we are doing the subsets by using these bit manipulations here. And how can we know the sum of those numbers? The sum of the quantity, the sum of those bit who has been converted from 1 to 0. That's going to be the question for us, right? And actually, there's another trick here. Instead of considering the ones has been changed from 1 to 0, let's consider the ones that has not been changed. And the ones that has not been changed to zeros are the numbers are the customers we're going to assign with the current index, with the current count here. So why we do that? Because at each of the while loop here, we have a current here. So the current is like this, something like this. And with this, we know, okay, so we have two numbers. We have two ones that we want to assign, two customers we want to assign. And then we can do some pre-calculations to just use O1 time to give us the sum. Because if we don't do a calculations, assuming we have this one here, we have to scan everything. We have to scan the entire mask, right? To get it, to check if this is 1. If it is 1, then we summarize the quantity. And we have to scan it for each of the mask here, each of the current one here. That's why we can simply do a pre-check here, a pre-calculation here. So we're gonna have like totals, right? The totals of the what? The totals will be the total quantities it needs for some of the customers, for some of the combination of the customers. And since we only have like 10 bit for 10 customers, so the total combinations for these totals, it's just like the what? 10 so like this, right? To the 1 to the power, basically to 10 to the power of 2 to the power of 10, which will be 10, 1024. Okay, and we can simply brute force to try all the possible combinations of of this bit mask, and we can pre-calculate the total quantities we need for any for the any of the mask with the with some given ones here, right? That's why we have a mask here in the range of this m here, right? And then we can have like, so for each of the mask, we simply just do what we're supposed to do here. We simply loop through each bit, and then we check if that bit value is 1. So the way we're tracking it, we simply do a if the bit mask, do an AND with the of this I here, right? If it's not empty, if it's not 0, then it's 1. Okay, yeah. And then we simply do a total dot mask, right? With plus of the quantity of that for that customer, right? So that's how we do a pre-calculation for any given mask, and how many quantities we need, so that in here with each of the current ones, the current mask, it means that the current one means that those are the customer. Again, we're trying to assign, right? So we just do this. If the totals of the current one, right, is equal or smaller than the count of index, right, then we can try our DP here. So we can try if now we can do a DP, right? The DP of index plus 1, right? And then we have a here. So okay, so again, right? So since we are going to assign the ones. Okay, let's say this is the current one, which means that we're going to assign with those two ones, right? With this kind of the current count. So what's gonna be the remaining bitwise, the mask? So assuming this is our original one. So as you guys can see, so if this two become 0, so the remaining one should be what? Should be 0, 0, 0, 0, and then 1, 0, 1, right? Which it means that we have already satisfied those two customers, and the remaining twos are this two here, right? And how can we do it? That this is another bitwise manipulations here, right? It's just the mask, right? Do a XOR with the current one. That's how we get the remaining one, because XOR means if they are the same, then it's 0. It will be 0. If they are different, then it's 1, right? So actually, this one is the same as if you can simply do a mask minus current. You will get the same result, because 1 minus 1 is 0, and then 1 minus 1 is 0. 1 minus 0 is 1, right? So either way, it's fine. And this one, if this one is true, and then we can simply return true here, right? Yep. I think that's it. Otherwise it will continue try the next subset, next subset, and then it will use the next subset to find the total quantities that subset needs, and then it will continue with this DP with the remaining ones, right? All right, cool. I think that's pretty much it. So let's try to run the code here. Total. Oh, I think I totals 39, line 39. Oh, okay, I'm missing an S here, I think. Yeah, 0. All right, accepted, submit. All right, cool. So it's success. Mm, yeah. Okay. So how about time and space complexity, right? So for the time complexity, so we need to get to know the total state. Let's say we have a we have an n here, right? N and m. So first one is the n, right? And then the second one is times the mass. The mass basically is a 2 to the power of m, right? And for each and then inside of each of the dp here, we're doing like a while loop here because we'll try to get all the subsets of the of the of the remaining. So it's going to be the total of subsets. Hmm. So let me think. So the subsets. Okay, and depending on here, this will be a little bit complicated because depending on how many ones we have here, right? Because how many ones we have in this state here, we'll do another subset based on those ones, right? It's going to be a subset. So, and to calculate subsets, actually, so it turns out, oh, by the way, so this, I believe this time complexity analysis should be out of scope. It'll be too hard. So it's gonna be a n times 3 to the power of m. So how do we get this? Basically, if you really want to dig into it, basically, there's if you guys know the a plus b to the power of n, so what's going to be the value for that? So it's going to be the a to the power of n plus a combination, right? So the combination of c n1, and then we do a to the power of n minus 1 b plus c, I think cn2 of a to the power of n minus 2, right? And then we have a b square, something like this, until all the way until to the end, to the b times b to the power of n. And it turns out the way we're calculating the bit mask and plus the way we're calculating the subsets is the same as this formula here. That's why we can just convert this 2 to the power of m times this subset, which is 3 plus m. It turns out to be a 2 plus 1 times to the power of n. And yeah, so that's it. I know it's complicated. Of course. So that's going to be the time complexity, and space complexity will be the state of this will be the n times 2 to the power of m, right? That's going to be the space complexity. Yeah, because for this part, it's running, it's a pre-processing. That's why it's faster. All right, cool guys. I think that's pretty much it is. I mean, this problem, the state, to come up with a state shouldn't be that hard, right? But the difficulty for this problem is the after you have figured out the DP state here. First thing first is that, after using the current index, even though there are like some numbers left for this current count, we'll be discarding those parts because we have tried all the possible subsets for this for for this current count. Even though there's not something we haven't assigned, we we have already tried all the scenarios. That's why we can safely move forward so that for this DP that's only the two state DP here. So that's the first thing. And the second one is the how can we use the mask here and to efficiently get the next subset. of a bit mask. And after getting the subset, and the third difficulty is how can we efficiently calculate the total quantities we need for the next subsets, right? And to do that, we do a pre-process, and then to represent we use the one the we use one to represent the people, the customer we're trying to satisfy next. Because the way this getting next subset works is by converting the ones into zero. That's why we have to start from all ones and then we end with all zeros. And that's why this one is a pretty hard problem. All right, I guess I have talked enough here. I'll just stop. All right, cool guys. Thank you so much for watching this video. Stay tuned. See you guys soon. Bye bye.